Okay, what's a relation? Anybody remember? It's the relationship. No, it's not a holy ship. It's a relationship of your input. What's the input? That's right, your x values. And your output. What's the output? Your y values. Thank you. Okay, what's domain? X values, right? Does anybody need one of these sheets? It's a note sheet in your packet. Are all x values? What's the range? Now, here's a good one. What's a function? Anybody remember? There is exactly one output. Now, what's the output? Y. So there's exactly one y for each input. And our input is x. Now, it doesn't. What this says is there's exactly one output y for each input x. That means x cannot have two different y's. Correct? Is that another way of putting it? If it does have two different y's, it is not a function. For example, in number 1, does every x have exactly one output? Does every x have exactly one y? No. So this is not a function. What's my domain for this? Yeah, it's my x values. It's the set of numbers of -3, 1, and 4. What's my range? My range is a set of numbers 3, -2, 1, and 4. That's not a function. Again, it's not a function because I have two outputs for the one input. How about number 2? Okay, so I got -3 goes to 3, 1 goes to 1, 3 goes to 1, 4 goes to -2. What's my domain? And my range? Okay, think about what a function is. Has exactly one output for each input. How many inputs do I have? How many outputs do I have? So just right away, I should know that there's going to be multiple outputs for the inputs, right? Because there's less of them. That's one way to determine that I might have a problem. Do I have a problem? Does every x have exactly one y? Does it? Yeah, sure, they could share y's. Then there's no problem. Be careful, okay? I was trying to set you up, and it looks like I did a pretty good job. Every x can have the same y value, but every x has to have only, can have multiple x's cannot have one y value. In other words, this 1 is twice multiple x going to two different values. All right. Back in Algebra 1, what kind of easy test did you determine if you had a graph to determine whether it was a function or not? Yeah, that vertical line test, right? Straight line. If you have a graph, actually you have a set of points here. If you're really confused on whether it's a function or not, really what you have to watch for is having two x's of the same value. Okay, if you have two x's of the same value, like we have two x's with the same value 1 here, it's not going to be a function. But you could always graph the points and use a vertical line test, right? Here I have a graph. Now, this is a closed circle that includes, I know these are not very good graphs. They didn't copy very well. Remember, this is my x-axis. This is my y-axis. Closed circle, closed circle means that these points are included in my graph. My vertical line test. If it hits, a vertical line hits my graph in more than one point, then it is not a function. So, very easily, is this a function? You didn't listen to me. You were goofing around playing with your hands with Riley.
You don't even know my name.
Riley. If it intersects, if it intersects at more than one point, it is not a function. It can intersect at exactly one point. Does this intersect at more than one point? No. So, is it a function? Yes. That's the vertical line test. Did you take Algebra 1? Who'd you have? Algebra 1 or geometry? Algebra 1 you should have taken at HH9.
Sure did. This is she has dark hair. Short dark hair. Talks a lot like this.
Mrs. Adams.
Sounds like a white girl. She dyes her hair kind of funky colors. That's why I have it. I just sorted. She was great.
What was it?
Do you like the set?
Sure I do. Sure I do.
Sure you do.
Okay, what's my domain? What's my domain for this graph?
How do you figure that out?
Well, look at my graph. What are the x values? Here's my graph.
So,
Right? What are my x values? Where does it start?
at 4.
-4 or -6. Okay, here's where it starts. My x value is -6. It's got a closed circle, so it includes the point -6. Then I go along my x-axis here, and it stops at +6, including the point +6. What's my range? Starts at -3, including the point -3, and it goes, its highest point is 4. If it's a closed circle at the end, yes. Remember, infinities never get brackets. We'll get to
Why
them.
is that not negative infinity? It's like,
It stops there. It's a closed circle.
oh,
Feels open. What would it?
It would be parentheses. If it had an arrowhead, it would be negative infinity. All right, how about the next one here? First of all, is it a function? Do your vertical line test. Does it intersect at more than one point? Here, let me highlight my graph.
No, it does not.
Does it intersect at more than one point?
No, it does not.
I have a vertical line here. Does it intersect this graph at more than one point? Then it's a function. How about this one on the back? Here's my function.
You know, this looks kind of familiar.
Here's my function. Does my vertical line intersect at more than one point? So this is not a function. Okay? I used to. Kind of got pushed out. So I'm like, screw it. Domain. My x values. Let's see, here's my x-axis. My graph starts right here, which is -7. It stops 6. How about my range? Let's see, it starts at, careful, -1. And it goes up to 8. Here's the top of my graph. My y value, remember I'm looking at this. My y's. Should we do a test? This is really reviewed.
Let it crack on a little bit more. We'll see how it goes about when.
Here's my graph.
That one intersects at more than one spot.
So it is not a function. What's my domain?
Okay, so would that mean then it would be at like -4?
Yeah, maybe a little bit more than -4. Yeah, -4.5. Pardon me?
And then the next one would be 7.
Yep, 7.
So then, hold on. So next is -2, 2. I think that's where that lies.
There you go.
It would be there.
How about number 4? Is it a function? Yepper. Okay, what's my domain? Where does my graph start on the x-axis? Careful, it's an arrowhead. Negative infinity, right? If this goes on forever, it's going to be negative infinity. Negative infinity, infinity always gets parentheses. How about positive? positive infinity.
How? Okay.
It's going on forever that way.
Whatever.
How about my range?
2, 2.
Where does it start?
2.
This is my y-axis, so it starts here. You tell me 2. Starts at 2. I see y values lower than 2. There's my lowest y value, which is 0. Thank you.
Wait, what?
This is my y-axis. Okay? Negative 3, negative 2, negative 1, 0. That's where it starts.
Oh, okay.
Okay?
And
It was, and then it's going to go up to, these go on forever. Infinite.
Is it always going to be like this? Or probably like
Maybe.
okay.
What about number 5? Here's my graph. It has arrowheads going opposite way from my x's. So what's going to be my...
Negative infinity.
There you go. What about my y values? Where does it start?
3.
Careful, negative 3. Where's it going to stop? Infinity. Is it a function? Vertical line test. Yeah. How about number 6?
Does that go down?
It looks like it starts here and goes that way.
Oh, okay.
Okay, so where's it start on my x-axis?
Does that look like a
Negative 5. Where does it stop? Infinity. How about the range? Where does it start?
Is that what? Can't be at 3.
Negative. Well, I'd say negative 3. This is where it starts. Negative 3. And it's going to go up to infinity. Is it a function?
Yes.
I'm assuming that it's going to go this way. Okay, so if you do a vertical line test. Number 7 is kind of fun.
Okay. So it's an intersect, like with the thingy where you use it or whatever. That means that it is a function, right?
Only once. Okay. This one's kind of tricky.
So that one wouldn't be because it does it more than once.
Correct. Because if you do it this way, it looks like it's hitting it twice. So it is not a function. What's the domain of this? Where does it start? Not quite. I'm going to say negative 6 3/4.
Actually, on your screen up here, it looks like 6. But maybe down there it is
6 and I'll say 6.5. Where does it stop? Good. And the range? Same thing, like negative 6.5, right? Okay.